Hello and welcome to it, Mindsetters. This is AP once more again on a lovely, lovely Thursday, and we are having a great lesson on Mets Lit, my favorite show. You know, how can I forget? This is one of my favorite subjects ever. Otherwise, you know by now that we've been doing revision throughout, and as grade 11s, we're giving you a chance to be on the grade 12 slot. How does that feel? Rather, we are saying to you, be like grade 11s from now on. Otherwise, talking about revision, we have this awesome competition whereby Samsung and Mindset have partnered together to bring you an awesome exam school revision marathon competition where you stand a chance of winning 3 of these Samsung tablets. As you can see, I have mine. Look at this. It has got a learning hub where you can access Mindset content, and some of the content that we have there, it's all for free. So feel free to go over the Samsung Learning Hub if you already have your Samsung tablet. But otherwise, if you don't have it, relax, because we're here for you. You could win one of the tablets, 3 of them. We also have 3 tabs, and also 3 of these Samsung Note 8.0. How nice is that? This is Mindset. You only get that on Mindset. Haley, how are you?
I'm well. How are you doing?
I'm fine. Hey,
it's good to be here.
You came at the right time. You know, last time when I saw you, we were doing measurements.
Is serious?
Can you remember?
I can't. I actually can't.
Well,
it was quite a while ago.
It's revision for both of us.
To see you all,
it's
guys.
revision for both of us. Otherwise, we're having this awesome competition. Would you like to win one?
I would love to. I'm sure there must be fine print though that we're not allowed to win.
Yeah, you're not, unfortunately, because I already. Well, I might give you one.
That would be
I might.
If I'm nice to you.
Yeah, I might.
If I make you not do math.
I might. Well, otherwise, I'll give you a chance to tell us what we're going over. Let me just give the Mindsetters a link on how they can win this, because we'd love to give you information. All you need to do is to download the notes, and also on the last page of the notes, look for the race number. There's a race number for this lesson. Otherwise, because I'm a nice guy, when time goes on, if I see that a lot of you are interacting with us on the page, I'll be a nice guy and give you the race number. But I'm not supposed to, but I feel like I should be a nice guy. Why not? And otherwise, you can also go to mindset.co.za/learn/win. And that's where you can access the awesome competition entry form, and you use that race number. Otherwise, Haley, what are we doing today?
Today we're going to be doing measurements, like you mentioned. We're going to be going over, this is for the grade 11, for exams. So I hope that you're focused, I hope that you're there, because I love this section, and yet I know a lot of you out there, this is your worst section. So hopefully by the end of the show, it's not going to be your worst section anymore. So
awesome. Let me give you the Mindsetters the links now. To interact with us, you must go to Facebook. It is facebook.com/learnextra. Join the 57,000 Mindsetters that are on the page. Chat to us, ask some questions, and get other Mindsetters to help you. Otherwise, you can follow us on Twitter @learnextra. And lastly, if you're stuck on anywhere, you need some extra help, it is in the middle of the night, you're studying alone, go to Help Desk. We are on mindset.co.za/help desk, or on Mixit. We have an application. On Mixit. But otherwise, from us and Samsung, for this awesome competition, enter now, Mindsetters, because the draw is coming very much soon. This is a leg 2 of the competition. Otherwise, last note is that Mindset and Samsung, that's where fantastic content meets great technology. Over to you, Haley.
Thank you. I was just thinking, as Amran was going through all of that, I wish that I had a mindset actually to help me when I was in grade 11 like you guys. Okay, so today we're going to be doing measurements. Let's see what the lesson's all about. Well, in this lesson, we're going to revise measurement calculations. Now, the best thing is I think I'm going to I'm going to do one thing first, and then I'm going to take you through 2 examples, and we're going to do that first. So when it comes to measurements, okay, I need to have more space. Is this the side? Right. When it comes to measurements, what we need to do is I can extend my page. We need to know that we are dealing in millimeters, centimeters, meters, and possibly even kilometers whenever we do calculations. The most important fact that I can tell you, and I'm probably going to say it over and over again, is check what measurement they want the answer in. So check your units. So let's make a list here. We need to check our units for the answer. And then once we've got the units that they want us in, we're then going to convert first. What you guys struggle with the most is these conversions, and especially converting squared, and cubed units. So I want you to convert first. If the answer needs to be in meters squared, convert to meters. If the answer needs to be in centimeters cubed, convert to centimeters. And now, before we carry on with the lesson, let us go through what our conversions are. Now, I like to think of it in one way. I know you might have used something else. You might have used King Henry. Whatever way you've been taught might be good. So I'm going to go over the way that I teach. I know that you have rulers on you. In your pencil case, you should have a ruler. So from a ruler, you can see that 10 millimeters is equal to 1 centimeter. That's just simple from the ruler. Then I want to know how many centimeters are in 1 meter. And this occurred to me the other day. Cent is the same as cents. How many cents in a rand? There are 100. Or per cent as being out of 100. So we know that there are 100 centimeters in a meter. So you can never forget that. And then finally, we want to know how many meters in 1 kilometer. And now we've got to think about this unit. So try and picture it. So I know that this is multiples of 10. I know it's not 10 centimeters, but 10 meters, because 10 meters is like your classroom's probably 10 meters. I know it's not 100 meters, because 100 meters, we think about athletes. They run 100 meters. So it has to be 1,000 meters. That's the only number that makes sense. Now what I do is I look at these numbers that I've written out, and you can write them out in your exam. You can write it out in the question. And then we use this to calculate. So when we convert from a big number to a small number, I'm going from the 10 to the 1, the only way I can do that is to divide. And when I go from the 1 to the 1,000, or the 1 to the 100, I'm going from a small number to a big number, only way I can do that is to multiply. Then what I do is, let's try to take another color. When I need to convert, so let's do an example. Let's convert 3.6 kilometers to centimeters. What I do is I check on my, I don't know how to move this up now. Is it there? Okay, we can't move it up. Struggling with this. Right, I check on my unit from one to the other. I'm going from kilometers to centimeters, from one side of the table to the other side of the table. That's what I'm looking at. I know that I need to multiply because I'm going that way. So I'm going to take my 3.6 and I'm going to say times by 1. And then I go step by step. So in the first step, I've got 3 zeros. So I times by 3 zeros. Then I'll go back to the other side of the table. Now I'm at the meters. From meters to centimeters is another 2 zeros. So I times by 100,000. And that will give me my answer. Then you can use your calculator because we've got calculators. So get our calculator out. And we can then say 3.6 times 100, that's 2 zeros, another 3 zeros, and we get 360,000. So that is 360,000. And don't forget your units. Really, really important that we have our units. Okay, let's move on to some questions, and we'll do some questions. Questions are not moving along. No, that's question 2. What happened to question 1? Question 1. Right. Question 1 has now been adapted from the 2012 DBE Exemplar Paper 1, question 2.4. So what we have here is we have a home theatre's woofer has a length of 8 inches, a height of 12 inches, and a width of 6 inches. So we are looking at those measurements, and it might be a good idea to actually draw that. So I'm going to go up a little bit. Right. There's my woofer. I'm going to actually draw that. I like to draw in pictures because it makes it easier for me to then answer the questions. So what do we know? We know the length is 8 inches. We know the height is 12 inches. And we know the width is 6 inches. So that's my 3D box. Now it's easier to answer the questions. Then it says calculate the volume of the woofer using the measurements given in inches. So my volume is length times width times height. And All we have to do now is substitute in the values. Now, what might also be helpful is if we go back to our drawing and let's add that this was my height, this was my length, and that was my width. Because if I add those units, now it's even easier for me to substitute because I've got all these values. So all I need is my volume equals what was my length. My length was 8 inches. And then what was my width? My width was 6 inches. And then finally, my height was 12 inches. Now, that looks very cumbersome with the number, with the word inches. So you don't need to put the units in at that point. I'm going to move this down a little bit if I can. Right, so it might have been easier to actually say it's 8 by 6 by 12. You can leave out your units in the calculation. And it might be a good idea to do so. Now, I know some of the kids that I teach, when it comes to meters squared, they get confused with the number. Like 2 meters squared, I'm just going to do this on the side while I'm thinking about it. 2 meters squared is just the number 2. The units are meters squared. But they tend to get confused and think, well, no, we need to take that 2 and square it. They do some funny things. So if that's going to confuse you, rather leave out the unit and just deal with the 2. But then don't forget to add the unit in your answer. So get our calculator out, and we've got 8 times 6 times 12, and we get answer of 576. That's 576, and that was inches cubed. Inches cubed. Now, we're not sure what the actual symbol for inches is, and they haven't given it to us in the question. So rather than actually using the unit, write it out as inches cubed. So I have got my unit, I've got my answer. Reread the question. Always important, calculate the volume using the measurements given in inches. Answered the question, I've gone back and I've reread. Why am I rereading? Because sometimes we miss little crucial facts, like rounding off correctly or we're using the wrong unit. So it's important to reread, and thereby we know we've answered the question correctly. The next part of the question says, if 1 inch is 2.54 centimeters, determine the height of the woofer in centimeters. So going back, I don't know if you remember, but our height was 12 inches. Now this, guys, is a pure ratio question. I love these ratio questions. So how do we do a ratio? We give what we've been given. We've got 1 inch is equal to 2.54 centimeters. And I want to know if it's 12 inches, how much is that in centimeters? And then I can deal with it like a ratio. So what do I do with the ratio? I say, well, what do I do to 1 to get it to 12? I times by 12. And I do the same thing on the other side. I times by 12. So in actual fact, I've got 12 times by 2.54 centimeters, and I can get my answer. Now, I know that some of you are going to be doing this instinctively. And my answer is 30.48. What do I mean by that? Some of you are thinking at the moment, why did she go through that whole ratio thing? We know we needed to multiply it. And I know instinctively a lot of you do know that, which is fine. You show the working, you get your answer. What I want you to do, though, is you know you need to multiply or divide. Make sense of the answer to make sure that you have done the correct thing. What do I mean by that? Is that 1 inch, I've got more centimeters. So I'm expecting my answer to be greater than 12. I've got 12, my answer was 30.48, that is bigger, so I know I'm on the right track. I multiplied when I should have multiplied, and I didn't divide. If you get an answer that's smaller, you've done the wrong operation. So always check that. Have we answered the question correctly? It just said, determine the height of the woofer in centimeters. So we've got our answer in centimeters, and that's perfect. We can try and move on to the next question. Right, question 2 is adapted again from the same paper, the paper 1, and now we're dealing with question 3.1. Right, I'm going to try and pronounce that. Now I'm going to ask Abraham to pronounce it. Miss Senokwane.
Sinokwane.
Senokwane. Okay, Senokwane is a squash coach at Katlego High School. She needs to repaint the walls of the squash court as well as renew the lines marking the various regions of the court. A 3D scale drawing of the squash court is shown on the next, well, got it on this page. Use the information in the diagram to answer the questions below. Now, before we carry on with the questions, I want us to actually look at the squash court. So, the squash court is shown. This is our 3D image. And these are all things that usually we struggle with. Can we actually see the 3D? What do we have? We have a front wall in front of us. It's an international squash single court. We've got an outline. Like I said, that's our front wall. This is a service line, and that's the tin. And then we've got measurements on the side. On a side wall, we've got a side wall which shows us the outline. On the floor, you can see this is the floor here, this darker grey. We've got a service box, the half court, and we've got measurements. Then it tells us as well that the right and back wall are removed for clarity. All measurements given are in millimeters, and all lines are 50 millimeters thick. I wonder if before we go on to do these questions, maybe we should take a little bit of a break.
I think we
Give
should
time
head
to
because
stretch.
everybody thinks I'm a bad guy about this whole race number. But I'll be a good guy and give you a clue or on where you can find the
that's a
race
good
number.
idea.
It is somewhere. So that is the clue I'm giving you guys. Otherwise, see you after the break. Welcome back, Mindsetters. Being in that break, I'm sure everyone is like, can we just relax a bit? Because, those 8 breaks are just so relaxing. I was like, it's time to learn again. But otherwise, Mindsetters, this is what the business is all about. It's time for us to learn more. If you still have some questions, go over Facebook. We are on facebook.com/learnextra. Like the page and join about 57,000 likes that we have, the Mindsetters that are talking on the page. Otherwise, the competition still goes on and strong. Your last clue is on Facebook. So the first clue was somewhere, and the second clue is on Facebook. Already the race number is on Facebook. So I will not repost. You just need to search it. It's just somewhere on the page.
It's somewhere on the page.
It's somewhere.
I love it. Okay, guys, welcome back. So while you were gone, I just had a look at this drawing that we had, and I realized that the numbers were just a little bit unclear. So I've rewritten all the numbers for you. And we're now going to actually use that in our calculations. So the first question says, write down the height of the tin section in centimeters. That's what's important to note. It's in centimeters. And remember what our diagram said? That all of these were in millimeters. So where's our tin? Our tin is there. We want the height of the tin. And so the height of the tin is that number there, 430. Let's move this down a little bit. I'm really struggling today with this board. It is 430, but remember that's millimeters, and this is where rereading the question would be so crucial. And we are going to divide by 10. So go back to those units that we had earlier, the 100,000, and we see that it is 43 centimeters. So got our answer. Let's carry on. Next part of the question says, calculate the distance in millimeters from the service line to the outline against the front wall. So let's go back to our picture, and we've got our front wall, and we're looking at the distance from the center. And let's show you which distance we're looking at. Let's draw a line. We are going from there to there. We want from the service line to the outline. Now, what measurements have we got? We've got up to the service line. We know that measurement is 1780. And then we know from the service line, let me get a pen. So we know up to the service line is 1780, and from the service line to the outline is 4570. So we've got the top, outline is there. So 1780 and 4580. Abraham, are you going to remember those numbers?
Yes.
1780. Okay, so let's draw this. What we have is we have the wall. we have the service line, and that was 1780. Am I right?
Yes.
And then to the outline was
5,
45
4, 5, 7.
4570.
I think.
He wasn't
let's
listening
double
to my numbers. Let's double check
double
the
check.
numbers. 4570, 1780. Whoops, I've lost my diagram. Right, 4570 and 1780. Right, so we want to know, now that was just that line, and that's that whole line. But we are looking for this part there. Now, what do we know about these opposite lines? That 4570 is equal to that. So if I take my 4570 and I minus up to the service line, I'm going to get the difference, because those two added together give me that. So let's do this. 4570 minus 1780. And we get an answer of 2790. What color were we in? 2790. And that is millimeters. They asked us for the answer in millimeters, so we've done that. We can move on to the next question. Perfect. The next question says, I'm fighting with this board today. Done that question. Right, question C says, calculate the area in millimeters squared. And I'm quite happy they're in millimeters, because you know what? Don't like converting. So millimeters, we know everything was in millimeters. Of the service box, and they've even given us the formula. So area is length times breadth. So area is our length times our breadth. And now we need to go back to our diagram to see where the service box is. Our service box is this box over here. Okay, and we know that that is length is 1600. That's my length. What is my breadth, my width? The length service is from there to there. That's my it's my service box is this one in the middle, not the whole box. So I've got 2610, but to that point was 4260. So I'm going to have 4260 minus 2610 is going to give me that part of the service box, which is what I'm looking for. So carry these numbers. 4260, 2610, 4260, and 2610. So we first have to get our length. So our breadth was actually, what was it?
4260
4260 minus
2610.
2610. That's going to give me my breadth. I know my length was 1600. So let's calculate that first. It's 4260 minus 2610, and I get an answer of 1650. And now my area is the 2 multiplied. Get a little bit more page here. So it's my length of 1600 times by 1650. And can you see, guys, that I have left off the units? Definitely tends to be easier. Calculator out. Calculation 1600 times by 1650. Get an answer of 264 and 4 zeros. Now remember, these are millimeters, millimeters squared. So there's lots of millimeters in this. Don't get lost with your calculator when you've got a huge number. Just make sure that you've got all the zeros. So we're actually looking at something that is 2,640,000, if you'd like to put it into words. That was 264 and 4 zeros. And now I need my units. That is millimeters squared. If I answered the question correctly, they asked for the calculation, the area, millimeters squared. I've done that, and I can move on to the next question. Right, my next question, and I've got my diagram again, and I should have put the numbers on again. The front wall and the 2 identical side walls are to be painted white, with the exception of the tin section, which is to be painted black. Calculate the area in meters squared that must be painted white. Now that's really, really important, because we've been dealing in millimeters, but they want us to do it in meters square, so we are going to convert first. And they give us the formula. Now, this is a formula that we haven't seen before. The formula says K, and then we open the bracket 2P plus B minus B times T. Now, this formula doesn't mean anything to you when you've got it like that. So go through step by step because they tell you what everything is. K is the height of the squash court. So I know what that is, including the outline section. P is the length of the squash court. B is the breadth of the squash court. And T is the height of the tin section. So let us fill those in here. K is the height of the squash court. Now I've got a picture of the squash court here. Height including it said including the outline section. So this is the outline section, which still needs to be painted. So that was 4830. That's K. I'm going to write it in here. 4830. P is the length of the squash court. Length of our squash court was this entire measurement, which was 6,400. B is the breadth. No, that was the breadth. Sorry, the length of the squash court. That was the breadth of the squash court. The breadth was 6,400. The length of the squash court is, that's my length, was 9750. That's my length of our squash court. And finally, the height of the tin section, we've done already, was 430. Now, I haven't put units in any of these, but we know these are all millimeters. So what I need to do is I need to convert them all to meters. So I'm going to do that first. So how many millimeters in a meter? Let's see if we can find a bit of space. Go back to my diagram. I know there's 10 millimeters in 1 centimeter, and cents is 100 in 1 meter. So to go from millimeters to centimeters, going from a big number to a small, I'm dividing. I'm going to divide by 1 0, and another 2 zeros, so it's 1,000. I need to divide by 1,000. Then we're going to go back and divide all of those. 4830, I'm going to do 1 on the calculator. I'm sure we can do the rest without. Divide by 1,000, and we'll see that we end up with 4.83. So that's 4.8. Let's try to write that again. 4.83. That's going to be 9.75, 6.4, and 0.43. Now you guys can check this all on your calculator. Now we're going to substitute into our formula. I'm going to rewrite my formula. My formula says, it said K, and then it said 2P plus, and it said 2P plus B minus T times, what is that? T times B. T times B times T. Now, substitute in the numbers. K was 4.83. So we've got 4.83, and open the bracket. 2 times P. And now the P makes sense that we've got the length of the squash court twice because we've got 2 walls. So it's 9.75. 2 times 9.75 plus the breadth, which was 6.4. 6.4. And we're going to minus the breadth times T, which was 0.43. Just going to go double check that. 0.43. And all we're going to do, guys, is substitute this into our formula exactly like that. Now, if you're using a normal 4-function calculator, then just be careful to do your BODMAS. So your brackets first, we're going to multiply first, we're going to multiply that first, then add, then multiply by the 4.3, and then we're going to minus after that. So be careful, brackets, and also we would multiply that as well. But our calculators can do this all for us. So let's get our calculator out. We're going to say 4.83 open my brackets, 2 times 9.75 plus 6.4, close that bracket. Maybe we should do this in steps. That's 125.097. 125.097. I haven't rounded off yet. Minus, calculator out, and that was 6.4 times 0.43, 2.752. And then answer, I'm going to say 125.097 minus that answer to get 122.345. 122.345. That's meters squared. Okay, and I'm going to round off now to 2 decimal places. So it's 122.35 meters squared. Got my answer in meters, so that's perfect. Done this all correctly. I think we've done, we've substituted into the formula, and we've got the answer in the form from the formula that they gave us. Can't move up anymore. Okay, now I can. So have we answered the question correctly? Calculate the area in meters squared that must be painted, and we've used their formula. So I think we've got it right. And I think maybe on that note, it's time to give you a little bit of a break. So I think hurry back. I'll see you soon.
Yes, it is, Haley. Talking about giving you guys a break, on the page, here's some few comments that I have. Remember, we are giving 3 of theirs already. One is won by CISO. So there's 2 more of the Galaxy Note 8.0, but we still have 3 Galaxy tabs and also 3 Galaxy tablets. Well, Mindsetters, we have some comments from Mula, who says, that one is mine. And some Mindsetters are saying, I'm going to pick up one soon. It's mine. I deserve it. It should be mine. It's mine. Well, I like that. Yeah, the enthusiasm, I like that. Remember, if you haven't entered for the competition, the race number is somewhere on the page. So look on the page and take that race number and then put it on the entry form. The entry form can be found on mindset.co.za/land/win. You should be knowing it by now. But otherwise, let's take a break. We'll see you after this. Welcome back, Mindsetters. I hope you're enjoying the revision lesson. If you still have some questions, feel free to ask us on our help desk, which is on mindset.co.za/help desk. Otherwise, add us on Mixit. We have an application where we can help you. That is our help desk. Otherwise, for this lesson, keep those questions coming also and your comments on Facebook. Haley, back to you.
Thanks. Okay, guys, so we finished question 2. So let's go on to question 3, because the best way to do this is by just practicing. So question 3, again from the exemplar paper, paper 1, question 4.2. A distance between 2 points on the map is 3 centimeters. The actual or real life kilometer distance between the 2 points is 15 kilometers. Now they want us to determine the scale used on the map in the form of 1 equals to whatever. And this is a perfect ratio again. I've got 3 centimeters on the map, so let's write down what I know is then 15 kilometers in real life. I want to know it in the form of 1 to something. But remember that your scale, when you come down to 1 to something, has no units, which means that we have to have the same units. So I cannot work in centimeters and kilometers, so I need to change that. So I'm going to change my 15 kilometers. I'm going to rewrite this as 3 centimeters, and I'm going to rewrite my 15 in centimeters. So on the side here, I'm going to say 15. I know I need to times it, and I'm quickly going to draw my 10, 100, 1,000, 111. I'm going centimeters are there, kilometers are there, so I need to times by 100,000. Let's move that over. See if I can move it over. 100,000. That's enough zeros. So I'm going to end up with 1,500,000. So let's rewrite and move this down a bit. So that's going to be 15 and 5 zeros. 1, 2, 3, 4, 5. So 1.5 million. Now I've got that in centimeters. Now I can go down to 1 to how much? And then again I do. What do I do from 3 to get to 1? Well, I divide by 3. So I'm going to do that on this side. I'm going to divide by 3. So extend my page a little bit. So I end up with 1.5 million centimeters, and we're going to divide it by 3, and it equals to, get your calculator out, always easier, just remember zeros, take them into account. So it was 15 and 1, 2, 3, 4, 5 zeros, divide by 3, we end up with 500,000. Count your zeros if you need to. Make sure that you've got the right number of zeros. So that is 500,000. And now don't forget that they want you to give the answer in 1 to the form of. So we've got to write it as 1 to 500,000. Once we've done that, we can move on. So we know we've given them question in the form they want it. So let's move on to the next question. Question 4 says, question 4, adapted from the same paper. I'm really struggling to move this down. The same paper, question, different paper. Question, paper 2, question 1.6. The recommended temperature to fry chips, chip twisters, is 220 degrees Celsius. The temperature of the deep fryer is given in degrees Fahrenheit, which is just typical. When you know the one value, then they give you the other. So what do we want? We want to convert 220 degrees Celsius into degrees Fahrenheit, and they use the following formula. So what we're going to do is we're going to use the formula that they give us, and it might be different to a formula that you've seen, but don't panic. Use the formula they give you. So we are looking for degrees Fahrenheit, and our formula is in the form of 1.8 plus 32 degrees times by degrees Celsius is 220. 220 degrees Celsius. Now, you might want to leave out the degrees, so you might want to rewrite this as 1.8 plus 32 times 220. And I'm looking at this, and this formula doesn't look right. I'm going to do the calculation. I think we've made a mistake here. 1.8 plus 32 times 220. There definitely is a mistake in this calculation. So, like I said, use the formula that they give you, but I'm sure that it's just a typing error that we've made in copying out this formula. And I'll tell you where the mistake is. This should be, so let's correct the formula. Degrees Fahrenheit is actually 1.8 times C plus 32. I'm sure that's going to give us a much better answer. So let's extend the page a little bit more. So it's 1.8 times 220 plus 32. Right, let's try that again. 1.8 times 220 plus 32. And again, that's a 428. That makes a whole lot more sense. 428 degrees Fahrenheit. But guys, if this should happen to you in the exam, and you've been given a formula and you've used the formula, and by mistake it happens, the examiners are human too, and it gets checked and rechecked, but it's possible that something like this could happen, that the formula would slip through. Answer what they've given you. Use the formula exactly the way they've given it to you, because they will pick that up when they start marking. They will pick up that everybody has done the same thing. Clearly, we made a mistake in the formula. So don't panic, because then you will be given those marks, even if your answer made no sense. And in fact, if you'd like, and you know it makes no sense, you can even write your examiner a little note. I did this exactly the way it was in the test. I know there's a mistake somewhere, but this is the answer I got.
Talking about those notes, Hailey, it
Yes.
shouldn't be a rude one, because you know what mindsets normally do. They'll get so much frustrated, and then they end up writing just anything that comes to their
Yeah.
mind because of frustration.
Absolutely. No, definitely. You've got to be very nice to your examiners. Very nice to your teachers.
Even in case they want to give you a mark.
In case they want to give you the right. Sometimes when I sit and I mark, and then I'll get like, because my kids know.
Yes.
If they've got a problem, then they must write me a note. And then I'll start giggling, and my husband will say to me, like, what are you laughing at? And okay, but then if they make me laugh, I feel better when I'm marking, and I'm more inclined to look for
Nice
marks.
one. That's a secret.
Secret to the world. I had a child give me a drawing of an alien. We were doing this section, and it's one of her worst sections. And she drew a picture of a ninja. And she said to me, the ninja's taken all her information away. She doesn't know how to do the section.
And what did you do?
Well, I couldn't mark anything. There was nothing to mark, unfortunately. Right. On that note of having some fun, let's move on to the next question. Right. Our next question is now the same paper 2, question 1.6. So, Rocco wants to redo the cushions on a couch in his living room. The couch has a rectangular cushion, which is 1.2 meters long, 45 centimeters wide, and 8 centimeters high. And it has 2 identical cylindrical cushions with a diameter of 18 centimeters and a length which is equal to the width of the rectangular cushion. Whoa, that's a lot of words. And we kind of think to ourselves, what are they talking about? But let's break it down. The cushions are made of foam, plastic, and then covered with material. So, firstly, there's our cushions. And what I'm going to do is I'm going to actually redraw this before we carry on, or we go to our questions. Let's see if I can find some space. Take out these numbers and actually redraw them into a picture. So now I've got a rectangular cushion. So there's my rectangle. And they've been given, I've got the length of the couch is 1.2 meters. So that's my cushion. It's 45 centimeters wide. So that's my 45 centimeters. And that's meters. And my width is, and it's 8 centimeters high. So that's 8 centimeters. Now, straight away, I can see that I've got centimeters and meters, and that poses a bit of a problem for me. I'm not going to think about it for now, keeping the drawing as it is. Then I've also got the rectangular cushions, so I'm going to draw my cushions this side. Right. The diameter, I've got the diameter of the cushions is 18 centimeters, so my diameter is 18 centimeters. Now, get into the habit, whenever you have a circle, a cylinder, where you've got a diameter, calculate the radius. So my radius is 9 centimeters. If we can get into that habit, makes it a whole lot easier. Because you know, guys, your formulas mostly have radii in it. And I'm looking for the length is equal to the width of the rectangular cushion. So my width of my rectangular cushion was 45 centimeters. How did we end up with 4.5? That's 45. So this is 45 centimeters. Right, now I've taken all those words and I've made them a whole lot easier to actually deal with. And now we can go ahead and answer the question. So the question says, use the following formulas if necessary. You've got your volume of a rectangular prism, the volume of a cylinder, the surface area of a cylinder, and they tell us to use pi. And I'm going to stop there for a second. Remember, you only need the 4-function calculator. On those 4-function calculators, there is no button pi. So we have to use pi equals 3,142. So get into the habit of using what they tell you to. So we're going to do that. That's perfect. And we've got length, breadth, height, and r is the radius. First question says, calculate, giving your answer in meters cubed, the volume of foam plastic needed in the rectangular cushion. So we're going to go back up to our equations, and we're going to see that our equation for volume is length times breadth times height. Now, let me go back to my drawing. I want to see if I can move my drawing. I wonder if I can move my drawing. Maybe we'll redraw the drawing.
The ninja has made it to stuck.
Let's redraw the drawing. So we had our drawing. That was, we'll finish the drawing, 1.2 meters. That was 45 centimeters. I keep doing 4.5. 45 centimeters. And the width was it 8? 8 centimeters. Okay. 8 centimeters. I want this in meters. So I'm going to do 2 things. I'm going to first say that's my length, that's my breadth, and that's my height. Other way around, it doesn't really matter. Remember, When you've got a diagram, multiply them, makes no difference. And I'm going to convert them all to meters. So I know centimeters, I need to divide by 100. I need to divide by 100, so I'm going to put that in. That's 0,45, and that's 0,08. And now my volume is my length, which I've got, 1.2, times my breadth, which is 0.45, and my height, which was 0,08. Get my calculator out, and that's all in meters. It's perfect. And 1.2 times by 0.45 times by 0.08, and I get an answer of 0.0432432. 0.0432 meters squared. So we got an answer, and that's perfect. I want us to now calculate one cylindrical cushion. So I'm going to get my cylindrical cushion, volume of a cylindrical cushion. Let's redraw my cylindrical cushion. My radius was 9 centimeters, and my height for this was 45 centimeters. Now, I tell you what, at this point, I'm actually going to do the calculation in centimeters to show you how to convert to meters cubed if we have centimeters cubed. So, the question said, always in meters cubed. First one we did in meters cubed. I'm going to show you this one in centimeters cubed. The formula for the cylinder is pi r squared h. That's my volume. So my volume equals 3,412. Drawing a bit of a blank here. 3,142. I don't know where that 4 knew that was wrong. 142. My radius is 9 squared times my height, which is 45. I'm going to get my answer in centimeters, and then we're going to convert. So, and I'll show you why it's so much easier to convert first. 3,142 times by 9 squared. Remember, if you don't have the if you don't have a scientific calculator, then it's 9 times 9 and times by the height of 45. And I get an answer of 11452. 11452, comma, let's go back to the calculator, 5,59, and that is centimeters cubed. Now I need to convert this to meters cubed because I wanted the answer in meters cubed. So what do? I know that there are 100 centimeters in 1 meter. So I'm going to divide by 100. But this is a cubed measurement, so I need to divide by 100 cubed. So all I need to divide by 100 3 times, 100, and then divide by 100, and then divide by 100. So let's do this on the calculator first. We'll take our answer, we divide by 100 cubed, and we get an answer of 0,011456. 0,011453, let's round to 5 decimal places, and that is meters cubed. Meters cubed, we write that. Okay. Alternatively, you take your calculator, let's go back to that original. What we would do if we need to divide it, I know you guys want to just divide by 100, but that's not enough. We need to divide by 100 once, we need to divide by 100 a second time, and we need to divide by 100 a third time to get the correct answer. The reason for this, I'm just going to quickly show you, is that if I look at a square, and this is just a square, we were dealing with a cube, and I look at 1 meter by 1 meter, and I'm looking at the area of that is 1 meter squared. But if I do the same thing in centimeters, that's 100 centimeters. And that's 100 centimeters. So my area is actually 100 times 100. So it's 100 squared centimeters squared. So I hope that actually makes sense, and I hope that helps. What did I say? Easier to convert first. That's what I said right at the beginning. So double check that we've answered the question. It said calculate, giving your answer meters, the volume of foam, the rectangular cushion we've done, and the, I've lost the question, the cylinder we've done. Okay, let's move on to the next question. Calculate how much foam plastic for the cushions will cost if they're sold at 400 Rand per cubic meter. So now we go back. I'm not going to actually do the calculation now. We're going to go back and we're going to calculate how many cubic meters we needed. And I think, in fact, let's just go back for a second. I think those calculations were quite small. So we had the first one we needed, okay, 0,0432. That was for the front, and then the cushions, we needed 0,0114. But remember, that was one cushion. We need two of these. So don't forget, we need two of those. So I'm going to leave you to do that calculation on your own. I'm pretty sure that you can do that. Calculate the cost, and it's 400 Rand per cubic meter. And let's see what the next part of the question is. Rocco calculated the total surface area of the cushions and stated that he would need approximately 2 meters squared of material to cover it. Verify showing all the necessary calculations if Rocco was correct or not. Now what you're going to do here is we're going to work out the surface area of the cylinder. I'm just going to write it out. I don't think I've got time to do this. Surface area of the rectangle. And then we're going to work out the surface area of the cylinder. And remember, there were two of those. We're going to times it by 2, and then we're going to add these. And then compare that to 2 meters squared. And we're going to do all of this in meters. But I want to go back and check if they actually gave us the formula for surface area. So back to our equations. Did they give us? They gave us the surface area of a cylinder and the surface area of a rectangle. So in actual fact, it's not too difficult. All you're going to do is substitute in. You've got all these measurements in meters already. And you can do the calculations and we can get an answer. Do you think I've got time to do these calculations?
I think we can try.
Shall we try? Let's see how we go.
Yeah, let's just see.
Let's see. So we're going to do first the, even if we just do the rectangle.
Wherever you're going to end it, the mindsetters will finish it off.
They'll finish it off.
Yes,
Okay, if I
I
can
trust
move down
them.
on this page. Right. Let's get some more space. Okay, so surface area of the rectangle. So let's do that's 1. We are doing this. It is 2 times the length times breadth plus length times height plus breadth times height. And go back to your diagram that you drew with your length, your breadth, your height. It'll be easier if I actually calculate. So this is 2 times, our length was 1.2 times by breadth 0.45 plus 1.2 times 0.08 plus 0.45 times 0.08. Now, whenever you get a sum like this, take it one step at a time. Substitute into your calculator. Just check that you're actually putting in the right numbers. Let's see if I can get you an answer. So we've got 2. We're going to open our brackets. 1.2 times 0.45 plus 1.2. Also check that you're putting in the correct sign, that it's not you're not meaning a plus in there, putting in a multiply. 1.2 times by 0.08 plus 0.45 times 0.08. Close that bracket. Get an answer of 1.344. 1.344. And that's now in meters squared. So I think that I'm going to have to say goodbye now. I'm sure you guys can do the cylinders on your own. So I'm going to say goodbye and good luck.
Unfortunately, that's where we end it, Mindsetters, but it's been a great evening. We wish you nothing else but the best. Remember that the repeats are on from 9 p.m. Otherwise, we just want to say peace. We love you all.